they are asking to identify what is the Young's modulus for a brass rod. Diameter is given. So the diameter of the rod is 25 mm. Length is given. Length is 250 mm. And they are also given what is the load and what is the extension after you apply the load. Right. So let us write what are the given data. So you have diameter D, which is equal to 25 mm. So in that case, I can identify what is my cross-sectional area. What will be my area? So it's a diameter. When I say diameter, your cross-section will be a circle, right? The circular cross-section, the formula for area is pi by 4d square or pi r square, right? So which I can write as pi by 4 into 25 square. So what will be the area? Can you tell me what is the area for this? Yeah, thank you. So it is 490.87 mm square, right? So this is my diameter. Next, length is given. Length is 250 mm. So I need to change anything. Next, load is given. Load is P. So P is given, which is 50 kilonewton. I'm writing in Newton, so it is 50 into 10 power 3 Newton, right? And change in length is also given, which is 0.3 mm, right? So you know only one formula. What is the formula? So del L is equal to PL by AE. Is my formula. So what are the things? So just look at this data. So change in length del L is identity. It is given. You have this P is known, L is known, A is known. The only unknown is E. That is what they are asking to identify. Okay. Just substitute it. You will get the value. So just substituting all these things. So we're getting 0.3 is equal to P is 50 into 10 power 3 into L 250 divided by A, which is 490.87 into E. So identify what is my E data. 84.88 into
10 power 3.
10 power 3. What is the unit? Can I tell you what is the unit?
Nm minus 2, so Newton per meter square.
Is it Newton per meter square or Newton per mm square? You should be very clear in your unit. So
mm
you
square,
check
sir.
Mm square.
yeah, you check your given data, everything is in Newton and mm, right? So the unit has to be Newton per mm square. So you have a rigid beam, right, which is supported by pin A, right? It is connected to two wires, BD and CE, and a force P is applied on the beam, right? So when you apply that force P, end C is displaced to 10 mm. End C is displaced to 10 mm. They are asking what will be the strain in your wire CE and BD. So it looks like somewhat complicated, but it is not complicated. So at least you should know what is your mathematical terms, right? So what happens here is I have a deflection. What is my deflection? So this is my deflection. So from here, let me consider it is deflecting like this. So you can able to see that. So you see that you have a pin support, which means it will bend. It is not bending. It is just rotating, right? You have a rotation here. Doesn't really. So this one length they are given. What is it? At C, you have 10 mm. Okay. So they are asking you what will be the strain at CE and BD. So what is the formula for strain? Formula for strain is change in length by original length. Okay. So for example, I want CE, right? Strain in CE will be equal to change in length. What is my change in length? 10 mm. It is already given in the question. So 10 mm divided by original length. What is my original length? What is my original length? Can you tell me what is your original length?
4, sir. 4 meter.
4 meter. So when you convert it into mm, it is 4000 mm. Okay. So in that case, what is my strain? So 10 divided by 4000. So we are getting 2.5 into 10 power minus 3. There is no unit for strain. Okay. So this is my answer. So this is my answer for the first one. The next one for BD. So here comes some trigonometric approach. So you consider that you have a straight line and an inclined line like this. So you know what is this length? This is 10 mm. Okay. So you know what is the total length which is given? 3 plus 2 plus 2. Right? So 5 plus 2, 7. So it is 7000 mm. I'm writing in mm. This is 7000. So this is my point C. Right? So now I need what is at B. What is my point B? So this is my line. Right? So in that case, I can also identify what is the length of this things. So totally it is 7000. What is this length? It is 3, right? So when I say it is 3, it is 3000. Okay. So this is 10. This is X. I don't know. And this is 3000. It is similar triangles. So whenever you have a similar triangle, so height divided by height of the other one. So I can split it into two this one, right? For easy explanation, so understanding purpose, I am splitting it like this. This is my first one, which is X and 3000. This is the next one, which is 10 and 7000, right? So these are the two terms. So you know that base of higher triangle divided by base of the smaller triangle is equal to height of this higher triangle divided by height of the smaller triangle. I can use that. So base of the higher triangle is 10 divided by height, base of the smaller triangle is x is equal to, and height of the smaller triangle is 3000. So I can identify what is the value of x. So x will be 30,000 divided by 7,000. Right? So what is the value?
4.28, sir.
So we're getting 4.28 mm. So now I identify what is the value of x. I can identify strain now. What is my strain formula? Strain BD. Change in length. Change in length is 4.28 divided by original length. So this deflection is 4.28. That's what we identified. Right? What is my original length? 4000. Right? So divided by 4000. So what is the value you are getting? 4.28 divided by 4000. So you're getting around 1.07 into 10 to the minus 3. Any doubt in this?
No, sir.
No, right? Okay. Can you go for the next one? Can I go for the next problem?
Yes, sir.
Yeah, we'll proceed with 1 16 mark problem now. So till now, the problem whatever we discuss is only 8 marks. This is 1 16 mark problem. So you can able to see here. So you have a tensile test piece, right? So the diameter of the steel rod is 10 mm, and the gauge length is length of the rod. Length of the rod is 50 mm, right? So the bar yields under a load of 20 kilonewton, right? So which means that is my yield strength, right? And it reaches a maximum load of 40 kilonewton, right? And it breaks at 25 kilonewton. Okay, you may think. So maximum load is 40 kilonewton. How it breaks at 25 kilonewton? Right? Because you know that when you look after the stress strain diagram, there will be a maximum point and then it will goes down. Okay, the down point is lesser strength. So because of the lesser strength, since it has reached the maximum, you have lesser values, so it will affect accordingly. So what they are asking to identify what is the yield strength, what is the ultimate strength, what is the breaking strength, what is the actual breaking strength if the diameter of the neck is 7 mm, then reduction in area and all these things. Okay, so this is one 16 mark problem. So they may ask something like this. So only thing is you have to identify the data and substitute it accordingly, right? So the strength, you see that you have two data here. So one is strength, but whatever we discuss here is stress. Both are same. Okay, strength and stress is similar. The formulas are similar. But what is strength? Strength is the maximum value. Stress is the value which is lesser than your strength. If I consider that you have a chair, right? The chair can hold 150 Newton, kg force, right? So what I say is a chair can hold 150 kg. That is my strength. But if you sit, you are around, let me consider 60 kg, right? So the 60 kg, whatever the value you are getting, that is stress. Okay. Only the maximum one, which is 150 kg, that is strength. Okay. So you have yield strength. So at the point of changing from elastic to plastic limit, that is what we got as a yield strength. Ultimate is maximum strength. Breaking is when it breaks. Okay. So the formula is same, which is forced by cross-sectional area. Okay, right. Let me consider what are the data given. So they write out the data. So they're given what is the diameter. So this is given data. They mention what is the diameter. So diameter is 10 mm. The diameter is 10 mm. What is your area? So it is a cross section area, right? So it is 5 by 4 into 10 square, right? So what you are getting? You're getting 78.53 mm square. Very good. So diameter is identified. So from the diameter, we identify what is the area. So next, gauge length. L is given. L is 50 mm. Right. Next, yield load is given. So yield load. So yield load. PY. Let me call. So is it equal to 20 kilonewton, which is 20 into 10 power 3. Next, ultimate maximum load is given. Right. Maximum load. Now, I want to identify what is my yield strength. Yield strength. So yield strength is yield load divided by cross sectional area. So yield load, you know, it is 20 divided by 3. And cross section area we already identified with 78.53. So 78.5. So what is my yield strength? 254.68 Newton per ounce. Any doubt on this?
No, sir.
Next, we need ultimate strength. So what is my ultimate strength? Okay. So ultimate strength is ultimate load divided by cross section area. So ultimate load is 40. So 40 into 10 power 3 divided by cross section area is 78.53. Right. What is my ultimate strength? It is 509.5 Newton per ounce squared. Next, fracture load. So I think the name is breaking strength. Okay, so they called as a breaking strength. Let me go for breaking strength. So a breaking strength is again breaking load by cross section area. What is my breaking load? 25 into 10 power 3, right? So PF divided by A, which is 25 into 10 power 3 divided by 78.53. So what is my breaking strength? Yeah, you are getting 318.34 Newton per ounce square. Okay, so we identified all these three data. So 1, 2, 3. So now they're asking what is actual breaking strength. Right? There are two stresses or two strength. One we call it as whatever we discussed, which is force by cross section area. Right. So the cross section area, there is one term called as before that. I will write it as initial cross section area. So this is what we are discussing till now. So all these stresses are forced by initial cross section area, right? But what happens when you apply a load? So diameter is reducing, right? So whenever you apply a load, your length is increasing and your diameter is reducing. So we have to consider that also. If you consider that, which means your formula will be similar to that, which is forced by, instead of initial, it is final cross section area. Final cross section area. This one we call it as actual or true strength. Actual or true strength. Okay. So they are asking what is the actual strength if the diameter of the neck is 7 mm. In that case, simple, my actual strength is force, which is 25 to 10 power 3. That is okay. But area is different. Now it is pi by 4 into what is my actual diameter at the time of breaking. It is 7. So 7 square. Pi by 4 into 7 square. So this is my value. So force by cross section area. But area, what you are considering, the final cross section area. Okay. So what is the value you are getting? So you are getting 649.61 Newton per mm square. Very good. So these data is identified. Okay, this is also over. Now they're asking what is the percentage of reduction in area, right? So how to identify reduction? How do you have two areas? Do you have two areas? One is a diameter 10. This is initial before you apply a load. Once you apply a load, it breaks, right? During breakage, your diameter is 7 mm. Okay, so I'm going to consider what is the area with respect to this, and I am going to identify. Okay, so what is my initial area? 10 mm diameter or 7 mm diameter?
10, sir. Yes,
10 mm is my initial area. So what you are going to do is to identify your percentage of reduction. It is initial area minus final area divided by initial area. This is always related divide by with respect to initial area. Right? What is my initial area? 10. So we are going to divide only with respect to 10. Okay. So you know what is my initial area, which we already identified. So initial area we know, which is 78.53 mm square. What is my final area? So final area is pi by 4 into 7 square. What is my final area? 38.48 mm. So percentage of reduction is equal to difference between the initial and final. So initial, I'll put this symbol indicating differences, right? Whichever is maximum, that has to become in the front. Okay, so always consider the positive value minus final. divided by initial. Okay, so which is equal to 78.53 minus 38.48 divided by 78.53. So this you have to multiply with 100 for to identify a percentage. So what is the reduction in your area?
51%.
50.99.
Sorry, 60, yeah?
51, sir.
50.99, sir.
51.99%. Very good. So we're getting 51.
50.99.
Sir,
50.
Okay, 50.99. So now we'll proceed with the next one. Percentage of elongation if the final gauge length is 67 mm. Right now we have to identify what is the elongation percentage. Right, what is the elongation percentage? So this is my 50 mm, it's my initial length, and this is my final length. Okay, so now percentage of elongation. Percentage of elongation. So this has to be final length minus initial length divided by initial length. Right, always your initial will be in the denominator. Okay, so hope look here. So here it is initial minus final. When you identify a reduction in area, it is initial minus final. Whereas here I am writing as final minus initial. The reason is whichever having higher value that has to be come front. As I told before, it is difference. Right? It is difference. It is not negative sign. There should not be any negative sign. It's just a difference. Okay. So final length here is 67. So 67 minus 50 divided by 50. Right? Into 100. So what is my percentage of elongation?
34.
34, sir.
Okay, 34%. Right? So this completes this problem.